Okay, so now we are doing section 8.4, which is solving quadratics by factoring. We have some steps, or this procedure that we can follow. So the first thing is we want to get a 0 on one side of the equation, if you don't already. Notice most of these problems already have one side of the equation set equal to 0. But for those bottom three, if it's not 0, we need to change that. And then once you have one side equal to 0, you will factor if needed. So also notice, I think the first two problems are already factored for us, so we don't have to do steps 1 or 2 for the first couple problems because they're already factored. Third step, we need to set each factored piece equal to 0. So that means every set of parentheses that's being multiplied has to be equal to 0 by itself. So we'll write out a couple separate equations. Last part, we just solve. So let's go ahead and try this. So for problem A, it's already set equal to 0 and it's already factored, so I don't have to do either of those. My next step, I need to set each factored piece equal to 0. So the way I do that is I look at my first parenthesis, n plus 8, and I'm just gonna set that equal to 0 on its own. Then I look at my other piece, 3n plus 2, and I set that equal to 0 on its own. And then I'm just going to solve both of these. So my final answer, I will actually have two solutions for my variable because I have two equations. So let's go ahead and solve. If I look at this first one, n plus 8 equals 0. This is a one-step equation. I just have to do the opposite operation and subtract 8 from both sides. And you should get n equals -8. For my other piece, it's a two-step equation. 3n plus 2, I have to subtract 2 from both sides. And this will get me 3n equal to -2. Then to solve for n, I need to divide by 3. And I should get n equals -2/3. So you may get fractions, you may not. But that is how we are solving these. So let's go ahead and look at B. This is extremely similar. So it's already set equal to 0. It's already factored. So we don't have to do those first two steps. What I want you to do is pause the video and try and solve. So you'll want to set each piece equal to 0 on its own and solve it. So you will get two answers. But go ahead and pause and try to solve this one. All right, so I got two solutions. The first one, b equals -2, and b equals 4 divided by 7. Okay, now looking over here at problem C, now we're gonna have to do a little bit of work. So it is set equal to 0 already, but it's not factored. So I'm gonna have to figure out how to factor this guy. So I know that I'll get two parentheses, one starting with r, and then another one starting with r since that's my variable. And then we can use our product sum to try and figure this guy out. So my sum, or my b value, is 3, because I have a 3 in front of my r. And my c value is -10, right? And notice I can just put my c value for the product since my a value is 1. So two numbers that multiply to -10 and add to 3, we're going to need a positive and a negative because our product is negative. So one of these numbers is negative. After some guess and check, you should be able to see that +5 and -2 are the numbers that we are after. Those add to 3 and multiply to -10. So we'll have r minus 2 as a factor and r plus 5 as a factor. So I'm going to set these equal to 0 on their own now. R minus 2 equals 0, and r plus 5 equals 0. These are both one-step equations, so I'll add 2 for this one, and I'll get r equals 2. And for this one, if I subtract 5 from both sides, I should get r equals -5. Now, I do want to point out really quick why we're doing this, because I know oftentimes in math we just kind of do the procedure, but we don't really know what's happening. So our goal is to find the solutions for the variable that turn the left side of the equation equal to 0, because that's the number on the right side. So The reason we split these off into two equations and solve them separately is because if I can get either one of these two parentheses to equal 0, this whole side will equal 0 because I'm multiplying them together. So if I end up solving and I get this parenthesis to be 0 and this one to be 4, I don't honestly care what this one is. As long as this one is 0, I know the the product will equal 0. And then in a similar fashion, if I can get this one to equal 0, I don't really care what this one equals. So when we solved and got n equals -8, if I substitute this value back in for n here, -8 plus 8, this does turn to 0. So that is why this is a solution. This number plugged in for n turns this whole side to 0. And then in a similar way, if I plug in -2/3 n, here I won't get 0 in this parenthesis, but I will in this parenthesis because that's the way we solved for this set. So that's just a quick explanation for why we're doing this. So take that as you will. Let's look at problem D. This is another one that is set equal to 0, but it is not factored. So we are going to have to do a little bit of work to figure this one out. Set up our product sum. Our B value is 5 and our C value is -14. A value is 1. So two numbers that multiply to -14 and add to 5. So one has to be negative since our product is negative. I believe we are going to want 2 and 7. There aren't many factors to choose from for 14, but -2 and 7 excuse me, should give us our product sum factors. So I have r minus 2 and r plus 7. If I solve these separately, r minus 2 equals 0, r plus 7 equals 0. I'll get, oops, didn't want to do that. We will have r equal to +2 for one of them, and we will have r equal to -7 for the other one. All right. Problem E. This is our last one where it's already solved for 0. I want you to try this one on your own. So you'll have to do your product sum, figure out what your factors are, and then once you have it factored, solve each individual parenthesis set equal to 0. Go. All right, I ended up getting k equals +6 and k equals -5. All right, looking at problem F. Now we have a little extra work to do. So now one of our sides is not equal to 0 yet. So first thing we have to do is turn that right side equal to 0, because obviously it would be a lot of work to get this side equal to 0, but it would be pretty easy over here. We just have to figure out how to get rid of that 8. So to do that, we're just going to subtract 8 off of both sides. And when I do that, my right side becomes 0. And then what happens to my left side? Well, if I subtract 8 from this whole side, I need to see, does it have any like terms over here? And it does. There's this 10. So I can do 10 and subtract off this 8, and that'll get me 2. And then I'll just add in the rest of the stuff. So then that's a +2. I still have the 5n. That's also still positive, and then I still have 3n squared. So now one of our sides equals 0. So that step is good. Next, we need to factor. So using our product sum, our b value is 5. Since our a value is not 1, the product is going to have to equal our a value multiplied with the c value. So in this case, that's 3 and 2. So 3 times 2 gets us 6 for our product. So we need two factors that add to 5 but multiply to 6. And funnily enough, they're the two factors I just wrote up here, our a and our c value. So that's just a coincidence. But if we have 2 and 3, those add together to give us 5, and those multiply together to get us 6. So from last section, we learned once we get our factors this way, when we had to multiply our a and c value for the product, we have to rewrite this with 4 terms, so that way we can factor it using grouping. So the way we do that is we have our 3n squared still, but the 2 and the 3 are going to replace our b value here. So I will have plus 2n and plus 3n. If I can write an n, there we go. And that is, this 2n and 3n are replacing the 5n. We're just splitting it up, so that way we can get some nicer factors. And then we still have that plus 2, and this equals 0. Now we can go ahead and factor out the GCF through grouping. So I have a blue group, I have a green group. With my blue group, I can factor out an n, and I'm left with 3n plus 2. With my second group, I actually can't factor out anything. It just has to say 3n plus 2. Oh my, something's going on. That's an n, I promise. But if you remember, it's very important that we have the same parenthesis, which we do. So 3n plus 2 is my first set of parentheses, my answer. My second set is whatever we factor out, which in this case, we only factored out an n here, and we technically didn't factor anything out over here, but I can imagine there being a 1 here, because I can technically pull a 1 out, because 1 is a factor of every number. And so if I pull a 1 out, that can act as my factor for that one. So n plus 1 is the second parenthesis. Now, this all still equals 0. So now, we finally get to our step where we can split up our parenthesis and solve. So 3n plus 2 equals 0, and n plus 1 equals 0. So now if I solve these, I subtract 1, and I get n equal to negative 1. That's one of my solutions. Up here, I would subtract 2, and I would get 3n equal to negative 2. And then to finish solving, I would divide both sides by 3. And so then for this solution, draw an arrow down here, n would equal negative 2/3. So longer process, but we still got to our two answers, n equals negative 1 and n equals negative 2/3. Okay, let's try another one like that. So once again, first step, I need to set the right side of the equation equal to 0. The way I can do that is getting rid of this 3. So I'll subtract 3 on both sides. As I do that, my right side of the equation equals 0. On the left side, I can subtract 3 from this negative 13, since they're like terms, and that would be negative 16. So you can use your calculator if you need to. And then I'm just going to copy down the rest of the equation that we didn't touch. Now that it's equal to 0, we can start looking for our factors. So let's look at our product sum. I have negative 2 as my b value. And then for my product, since my a value, again, is not 1, it's 3, I have to multiply this number by my c value. So 3 times negative 16 is going to give us negative 48. And I got that by taking 3 times negative 16. Okay, so now our product is negative, which means one of our factors is negative. And we need two numbers that multiply to negative 48 and add to negative 2. Let's just start listing some of these factors of 48. So we have 1 and 48. We have 2 and 24. We have 3 and 16. So far, I don't think any of those are going to add to 2, or negative 2. Let's keep going. We have 4 and 12. Still, I don't think that'll work. 5 doesn't go into 48. 6 and 8. That looks like they'll add to 2. So let's try this. If my sum has to be negative, the larger number needs to be negative. So negative 8 plus 6 would equal negative 2, and negative 8 times 6 would get negative 48. So I think we found our winner. So now these two numbers are going to replace my b value as I rewrite this equation. So I have 3n squared minus 8n plus 6n and then I still have my minus 16, and this equation still equals 0. So once again, negative 2n just became negative 8n plus 6n. Same value, just expressed differently. Next, we're going to group. So I have my blue group, I got my green group. Out of the blue group, I can factor out an n, and I have 3n minus 8. And then out of the green group, looks like I can factor out a 2, and I'm left with 3n minus, oh my goodness, 8. And this still equals 0. So my parentheses are the same, so I know I did my grouping correct. So I have 3n minus 8 as my first parenthesis. My second parenthesis is made up of what I factored out of those two groups, so n plus 2. Last step, I can set these equal to 0 separately. So 3n minus 8 equals 0, and n plus 2 equals 0. This is a two-step equation, so I'll add 8 to both sides. 3n equals 8, and then I divide both sides by 3, and I get a fraction, but that's okay. N equals 8/3. Over here, it's just a one-step equation, so I subtract 2 from both sides, and n equals negative 2. All right, so using all of our skills, this problem is very similar to the last two that we just did. So you need to get the right side equal to 0 first, and then after that you factor and set each individual factored piece equal to 0. So I want you to pause, go ahead and try this one on your own, and then unpause and see if you got the correct solution.